right, the next section is about the radius of convergence. And it actually, 10.13 actually has two sections. So we're only going to learn about radius of convergence today. So your goal today is to determine the radius of convergence for a power series. Before we can do that, we need to know what the heck is a power series. A power series is going to be an infinite series, but instead of just having numbers in it, a power series has a variable in it. So we're going to have a coefficient, c sub n. It would be a different coefficient for every value of n, or maybe the same one, but c sub n could be different for every value of n. And then we're going to have our variable x minus a, because we're going to be centered at a, and then to the nth power. So really, in English, this is an infinite polynomial that is centered at x equals a. The difference today between what we did yesterday with Taylor series, or what we did this week with Taylor series, is that these are infinite. I'm sorry, I said Taylor series. Taylor polynomials are finite. There is a number here rather than an infinity here. Taylor series can be infinite, so we're going to get into that later. Anyway, we have an infinite polynomial that's centered at x equals a, and n is the degree of the term that you're on. All right. So if you have a power series, there are three options for convergence. The first option is that it converges for only one value of x. Remember, we're going to use all of our convergence tests here. The other option is that your power series converges for some interval centered at x equals a. And the third option is that your power series actually converges for every single x. If your power series converges for one value of x, that value of x is the center, x equals a, and your radius of convergence is 0. If it converges on an interval, then your radius of convergence is half of the width of that interval, because you'll add and subtract the radius of convergence to a to get the interval of convergence. And the interval may or may not include the endpoints. Tomorrow will be all about figuring out whether the endpoints are included. Today will be about figuring out the radius. The third option is that your power series converges for all real numbers, in which case the radius of convergence is infinity. And how do we find the radius of convergence? We think of Yoda, and Yoda says, use the ratio test, Luke. Okay, so we're going to start with this example. We're going to find the radius of convergence. So we're going to use the ratio test to do this, because Yoda told us to. And the ratio test is the one that says we're going to do the limit as n goes to infinity of a sub, we're going to take the n plus 1th term divided by the nth term, and if that's less than 1, then our series converges. If it's equal to 1, then our series diverges. So we're going to set that limit to be less than 1 so that we can figure out what the radius of convergence is. The only thing that we're going to add today is that if you're going to use the ratio test, your terms all have to be positive. That's one of the prerequisites for the ratio test. N is positive because it goes from 0 to infinity. 10 to the n is positive because it's exponential. X to the n, well, because it's a positive exponential. X to the n might be positive or negative depending on what x is. So what we're going to do to fix that is we're going to put absolute value bars around our terms while we do the ratio test. All right. So we're going to do that. Oops, we're going to do that for this one. We're going to do the limit as n goes to infinity of n plus 1, x to the n plus 1, over 10 to the n plus 1. And then rather than dividing by a sub n, I'm going to multiply by the reciprocal. So I'm going to multiply by 10 to the n over n times x to the n plus n, not plus 1, just n. And that's going to be all inside of absolute value bars. We want this to be less than 1. Okay, now we're going to simplify that as much as we can. I'm kind of going to gather like terms together. So I will have n plus 1 over n. And I will have 1 over 10. And I will have x. Now if n is going to infinity, this is going to go to 1. So I have 1/10 of x is less than 1. In order to solve for x here, I'm going to split this into, I'm going to rewrite it, so it's going to be -1 is less than 1/10 x is less than 1 to get rid of my absolute value bars. And then I'm going to multiply by 10. So I have -10 is less than x is less than 10. Our center is x equals 0 here, so our center is 0. And our radius, so we're centered at 0, and our radius is 10 in both directions. The thing to be careful of is right now and until tomorrow, we don't know whether these signs are correct. We don't know whether these signs have less than or equal to bars or not. But we do know that the radius of convergence is 10. All right. We're going to do this next one, the radius of convergence for this one. All right, so we're going to do that ratio test again. We're going to take the limit as n goes to infinity. Again, we need absolute value bars. Again, we're centered at 0 because this doesn't have an x minus a. We can't see the a. And so we're going to do x to the 2 n plus 1 over n plus 1 factorial. And then we're going to multiply by the reciprocal instead of dividing. So we're going to do n factorial over x to the 2n plus 1. I'm going to gather my like terms again. 2n plus 3, right? And then my factorials cancel, and I get 1 over n plus 1. And I want to make sure this limit is less than 1. All right. What I notice is that this goes to 0. So no matter what x is, this will be less than 1. So that means that this radius of convergence is going to be all x. So the radius is infinite. The interval of convergence is all real x, negative infinity to infinity, and the radius of convergence is infinite. All right, we're going to do 2 more. Find the radius of convergence here. So same setup. This one again is centered at 0. When I throw these absolute value bars around it, I can see for sure that I don't care about that alternating series. So I'm going to just do x to the n plus 1 over n plus 1, because if it's got absolute value bars around it, it's not going to alternate signs anymore. And then I'm going to multiply by the reciprocal, x to the n. Nope, reciprocal. So I'm going to put that on the bottom. And I want to make sure that's less than 1. Gather like terms again. And I have x times n over n plus 1. This is going to go to 1. So I have absolute value of x is less than 1. Or in other words, -1 is less than x is less than 1. So my radius is 1. All right, last example, find the radius of convergence here. This one is centered at 4, so it's a different center, but we can still do our same process. So we're going to do the limit as n goes to infinity of the absolute value of n plus 1 factorial times x minus 4 to the n plus 1, and then we're going to divide by n factorial times x minus 4 to the n. And we want to make sure that's less than 1. And we get n plus 1 times x minus 4 to the 1 power. And this part is going to go to infinity. So the only way for this to converge is if x is equal to 4, so that we have a value of 0. So the radius of convergence is going to be, that's not the radius of convergence, sorry. The radius of convergence is going to be 0 because there's only one value, it's the center. That's the answer. All right, so those are the three possibilities. Here's one where you have an example where the radius is 0, where we only converge at x equals 4. Here's an example where the radius is 1. And here's an example where the radius is infinite. So you have, those are your three options. All right, good luck, have fun today. Thank you.